My name is Elliott Samuel, first of all, I want to thank all of you guys for coming out for this session on water in the built environment and just getting a greater understanding of how to leverage the IoT in order to sort of mitigate risk and find greater efficiencies across these different environments. So we'll pretty much be discussing water risk primarily, IoT technology, communication infrastructures, as well as the value of the data generated. So just before we move into some of the real content, I'll do a little shameless plug. So as I mentioned, I'm director of prop tech for this company called EDDY Solutions. Basically, we're a North American manufacturer of leak prevention products, but we also provide services where we're essentially monitoring all classes of real estate as it relates to flow, sensory data, in terms of the water consumption across these environments, and we're able to significantly mitigate risk by shutting that water off in terms of those acute events, as well as drive data to help prevent future events in key areas of the buildings which people don't really get data from historically and are looking to avoid and mitigate risks. Just a little bit about EDDY. We've been around for about 5 years now. We started out in the residential sector, and we were pulled into the multi-residential sector just based on market need. I'll run through some case studies a little bit later on and some of that data, and just finish off with this. I personally, while I'm director of prop tech, I have a little bit of history in the restoration industry. So I used to be on the other side of this. You know, when people would experience losses, I'd be the guy who'd come in with my crew and my DUs and all my machinery, and about $500,000 later, my quarter would be made. So now I saw this company come into play, I saw their products, and I essentially made it part of my mission to join this company and to help educate the market on just what a significant risk this is and how we can get ahead of it. Here's just a lovely little video for you guys. This is a bit of a hydronic loss taking place inside of a building. And basically the reason they're not opening the door there is because they can't. Because all the water is pressed up against it, and there's the weight of the door there. But I sort of look at water damage in the real estate industry as essentially like equivalent to the mental health issue in society, in that everybody within real estate deals with this issue, and ultimately it's basically swept under the rug. It's moved into next year's budget because, you know, oftentimes there needs to be a vertical garden hung in the lobby, or there's a concrete resurfacing project which takes priority. But part of this is just a matter of perception, and that people have sort of historically felt that, okay, this is just something I have to deal with as a consequence of, you know, operating in these environments. But the reality is you would never walk into, you know, a new build that's not going to have fire suppression in multifamily and commercial space. It's not going to have camera systems. The only difference is we're trying to work with the industry to check the largest risk that they have inside of their buildings, which is essentially water. So just breaking down some of those statistics based on what, you know, some of our learnings in the marketplace, nearly 60% of basically every single real estate claim is going to be water damage by percentage value, and nearly just over 70% by dollar value as it relates to these real estate claims, and about 50% of all residential real estate claims are water damage issues. Now, this is just the claims data, not what people are using out of pocket in order to avoid claims and avoid paying their deductibles and things like that. So the actual numbers are significantly higher. And, you know, just as an example, because water represents such a significant risk, it doesn't matter what life cycle the asset is in. From course of construction, basically when people are on their builder's risk, into operating environments, we see this risk is extremely prevalent. Like, just as an example, I believe Zurich, on just course of construction alone, spends about $120 million a year on their water damage claims. They could literally invest $100 million into their entire portfolio that they're monitoring and that they're insuring and be net positive in year one. So there's great opportunity because there's such huge losses taking place inside of these environments. So just in terms of addressing risks in the building, so as you saw in the previous slide, it's not really a matter of if but when you experience a water event. And really it just comes down to determining what is preventable and what is not preventable. So as we look at this, we can see about 45% of these losses are going to be based on burst pipes. But if you aggregate that around, based on the current state of technology, about 99% of these forms of losses can be detected in a much quicker fashion. I would say about 80% of them, as related to interior sources of risk, can currently be mitigated. And that's through a combination of sensors, meters, and shutoff valves strategically placed across the distribution systems of these buildings. And it's all going to be sort of real estate class by real estate class in terms of how you would approach that. And basically, outside of sprinkler discharge, I would say, because nobody's going to be shutting water off on the sprinklers, every one of these issues from the interior source can be dealt with. And basically the objective should be, because the tools are available now, where you would have experienced a multi-level loss historically, if we can turn those into mop and towel cleanups and significantly reduce the mess and the operating expense associated with these losses, that's ultimately the objective, because it's going to happen one way or the other at different points in time during the life cycle of the asset. But without taking any action, essentially, operators make themselves susceptible. Operating a facility is difficult enough as it is, but when you add into it, the cost to bring the infrastructure back to pre-loss condition after you've experienced those losses, or the potential environmental issues that can stem from water damage across, these environments. There's the liability associated with it, as well as the insurance-related costs that's going to be a burden on the building as a result of these losses. And then, there's the residents, the tenants, the inhabitants of the building, whether it's a business operating environment, you're displacing people one way or the other, whether it's a family or whether it's a business that's going to be operating. And at the same time, those that are operating the facility are going to experience business interruption outside of what they're normally conducting. So there's a pretty high price to pay. And because water represents the largest risk inside of the built environment, especially in vertically oriented properties, this risk has always been sort of a reactive measure where people are waiting for the damage to take place, and then they're taking action after the fact because they haven't had the tools in place that can financially make sense, that from a technology perspective will actually work given all of the, interference inside of these types of buildings and these types of structures. And basically now with the power of the IoT, there's so much more that you can actually do in order to prevent this. So just, use your imagination with me for a moment, and just imagine here we have a building where, let's imagine at 3 a.m. on a Tuesday evening, riser pipe springs a leak between the 5th and 6th floor. Typically, the way that this happens is water floods through the apartments, maybe down 2 floors, 3 floors, and by the time it gets noticed, you're already a few floors down. Much of the damage has been done, and it's continuing to persist until somebody can actually take action, shut off the water. The end result of a scenario like this is about $900,000 in claims many times. You might have 7 families displaced. Insurance premiums are going to be increasing, as well as paid out deductibles. There's potential environmental issues inside of the building post-loss, and not to mention, there's that, and then there's the external cost as it relates to human capital loss during business interruption, all the externalities that are associated with these types of losses. Now, leveraging the power of the IoT, we can see sort of what the impact could be here. If that same leak had sprung with the right technology in place between the 5th and 6th floor, imagine that you had tools that would detect water presence, detect the flow of water inside of these environments, and based on collecting that data, be able to shut that water off within a minute to a few minutes of that leak taking place. You're talking about significant savings. You're avoiding major loss factors over the property, and essentially the objective there would be turn that into a mop and towel cleanup. There's no reason for that to be an insurance claim at this stage, because we already have the technology that's in place, and we're proving this day in and day out. At least at EDDY, we're doing so, and we're working with the right stakeholders as it relates to insurers, as it relates to brokers, as it relates to developers, property managers, and large family offices and REITs. But that's ultimately the power of the IoT. So that's part of what's been spurring on this growth, and ultimately this is a phenomenon. And the reason that it's a phenomenon now is primarily on the basis of where technology is today versus where it was, because there were extreme historical limitations as it related to these systems. Ultimately, the 2 main limitations would be communication infrastructure, as well as a cost-effective and scalable means to get this technology inside of a building, because historically, in order to get a system where you're going to be able to touch all the key points in a large facility, you need to wire that in. Wiring that in, the cost of that would be astronomical across most of these buildings, and maintenance would be impossible after years. Now, with current state technology, we've seen this massive growth, and it's expected by 2020 there's going to be over 26 billion connected devices. The cost is being driven down by a significant margin in terms of the way that these are monetized now, whether people want to take on capital expense or whether they want to amortize capital expenses as part of an operational budget. All of these things are now possible under these new setups. In addition to that, these systems are drawing far less energy than traditional systems have, so it's not going to cause a burden to the actual operating environment in the building, and the network has been extended by a significant margin, ensuring that you have extended coverage and extremely low latency as it relates to devices communicating on site and getting the data across to the key stakeholders when it needs to get out. So as we can see, there's been some massive increases and adoption's been pretty steady over the last little while on the IoT. And you can sort of see how it trends upwards. The bottom end with the blue is going to be the consumer base. Business cross-industry is red, and business vertical specific is going to be the gray. One of the interesting things to note is that as time goes on, this gap between consumer-driven solutions in the IoT and business-related focus is actually getting smaller. There's been major adoption and there's growth in specific verticals and sectors. So just to get a better understanding of where that technology is getting leveraged more and more across these environments, we'll sort of take a look at a global representation of current IoT projects and future IoT projects. One of the things that you'll notice is in the trend box, the two top trending areas, even though it doesn't represent the largest percentage, is connected building and smart cities. Right, smart cities actually represents the largest, and part of that is because there's the greatest opportunity to make a difference in those two environments. And once again, a lot of it comes down to communication restrictions and the way that previous systems were structured, not making it possible for municipalities and buildings to scale these solutions effectively. But the drivers behind these are essentially, same as in most businesses operating. It's going to be efficiency, it's going to be cost savings, a focus on, the environment as well as it relates to municipalities, as it relates to buildings. Everybody would like to have their building or their asset be in a class where, if they're not currently part of a REIT, they could be sold to a REIT in the future. So there's certain standards which need to be applied to those operating environments. In addition, there's a duty of care element as it relates to the built environment, as it relates to municipalities, which the IoT is just extending the power and the ability for these municipalities, for these building operators to actually have connected buildings and be able to take care of the potential issues that would take place. So outside of water, there's thousands of other solutions that provide insight into the way the buildings operate, and just leveraging the right networks can help these scale. So how ultimately is that achieved? When we take a look, just to break this down a little bit, you've got your technologies on the exterior there, network standards, augmented intelligence, augmented behavior, and sensors. And you have your stages, create, communicate, aggregate, analyze, and act, as well as your value drivers on the interior, magnitude, risk, and time. And essentially what we're looking to do is start the process driving with the devices that are on site, taking in the critical data that you need to get in order to take action. But before that happens, once that data is picked up on site, you need the right communication infrastructure in place so that it can effectively communicate it. And you can get that data aggregated into an appropriate database where it's going to be able to be analyzed, and that's where essentially the analysis comes in. So depending on what type of systems you're looking at, there's a variety of different ways. Some are going to be based on artificial thresholding. There's going to be a lot of systems that are based on behavioral learning, some that are AI, and some that are quasi-AI. So just be careful with some of that, because there's a lot of behavioral learning dressed up as AI. And sometimes the solution doesn't even require true AI, depending on what the issues are, because it could be very, very binary variables that will be able to tell you what's going on inside of these operating environments. But essentially, the most critical stage is action. Once you've gotten this data in place, once you've databased it, once you've analyzed this, how do we augment behaviors to ensure that these risks are being avoided in the future? And even in current stage, let's say you're receiving a critical alert at this moment in time, is there automation, is there manual intervention that takes place in order to deal with this issue? That is the key. And ultimately, IoT, as great as it is, it's not a silver bullet, in that people need to actually leverage the data the appropriate way and understand what the use case is that's driving this data in, so that they're able to really mitigate their risks and get a better understanding of efficiencies inside of their operating environments. So this comes with a set of challenges. And typically what we've seen historically is battery life is going to be a major challenge when it comes to wireless devices. depending on the systems you leverage. Once again, technology is going to make a major difference in terms of the lifespan of the devices, as well as the communication infrastructure. In addition to that, you've got, in order to connect these buildings, especially in the CRE space, like the commercial space, you will likely have business flow processes which need to take place as a result of data being inputted into the system. So one side of it is going to be integration with the BAS and BMS systems inside of these buildings, ensuring that when a valve is shut off on a critical line, that the pump which follows it is also going to be able to take action and communicate, thereby mitigating risk on the efficiency side of the equipment and ensuring that there's no damage to the plumbing system. But also, let's say you're in a commercial environment, you're going to have business flow processes to follow. So you might have microservices providers aggregating all your different IoT projects into one place. So when one thing happens, it's going to trigger a chain of events, right? You have a loss, you shut down a line, now you may need a restoration company to come in and deal with some of the issues. You may need a plumber to come in and correct the source. You may need a maintenance person in place. And all these business flow processes need to work with each other in order to efficiently operate inside of these commercial environments. And so, you've got challenges, things like legacy technology. How do we get the BAS systems to operate with these new IoT projects which are coming in, and how do we get the communication between these two to actually work? And there's typically going to be some political resistance internally in a lot of organizations as it relates to IT and involving other IoT projects as part of the communication infrastructure and stack. As well, the built environment represents some really significant challenges that we don't experience in most other technological spaces. Like, pretty much all around us is just insulating factors. There's concrete, there's rebar, everything's designed to stop signals. And so in order to have an effective solution in place, you need to have a network in place that's going to deal with those different elements and that's designed for the specific use cases. And then as well, when you're talking about these projects, everybody's eyes are a little bit bigger than their stomachs at the end of the day. So there's a million things you can do. Everybody wants to do everything, but eventually there's a cost that's associated with it, especially if you're looking at, capital expenditures, or if you're looking at them as operational expenses. Different environments are going to have limitations for what you can do, whether it's in the commercial space, multifamily, or whether you're talking about a condo project. There's all different limitations, and the different environments need to be able to bear those costs effectively in order to make them actually feasible and scalable for them. Because really where, on a transactional basis, one by one, this is fantastic, but really where there's great value is geographically dispersed real estate, where there's a lot of risk vertically stacked. That's where you can provide the largest impact because it's so widespread and it's prevalent in virtually all of these environments. So, you sort of have to pick and choose how you connect devices and what sort of communication infrastructures you're looking at. So typically, historically, the IoT has gotten a bit of a bad name because a lot of times the use cases and the communication infrastructures were not aligned for the environments. So using, sort of short-range networks, Bluetooth, Zigbee, Z-Wave, mesh networks even across these buildings, or cellular LTE networks were not designed for this type of environment. Like, it can communicate with endpoint devices, but typically it's at a high cost, it's at a high energy cost, it's at high complexity and very low reliability when you're trying to deal with that. So what we've actually seen is inside of the built environment, inside of municipal environments, LPWAN'S, so low-powered wide area networks, seem to be the most scalable, cost-effective, and robust networks to be able to provide these types of communication infrastructure where you might have a sensor sitting inside of a distribution panel inside of the middle of a building. How do you get a consistent signal from that sensor over a 7 or 10 year period and ensure that there's no lost reads, there's no dying equipment? It all comes down to ensuring that you have the right use case and the right communication infrastructure to support the projects. So just as an example, LoRaWAN is one of the LPWANs that's pretty prevalent in the marketplace. That's what our company uses in terms of our communication infrastructure. If you're looking at it inside of a built environment, it's phenomenally scalable. It's really cost effective because ultimately once you have the infrastructure in place, there's thousands of other endpoint devices and services that can scale off the same networks, and your monthly cost isn't going to essentially go up on the back of that because you can connect so many devices on a gateway by gateway basis. But for municipal services that are pretty widespread, they have micro gateways that are able to communicate over extremely long distances. I think the last record that was set was about 760 kilometers where it's communicating. So you could imagine for municipalities looking to upgrade old remote reading infrastructure to automated metering infrastructure, looking to get data from disposal systems, pest control, lighting, whatever it is across infrastructure, it's extremely scalable, and it allows for a low cost to be associated with picking up all that data. Now, it's not necessarily designed for every single type of technology. Like, I probably would not be putting video on an LPWAN type of server because it's designed for smaller packet loads. So when you're getting more binary information, more information related to these environments where it's more of a yes-no type of scenario, that's where I'd say there's great use in these LPWAN networks. And we learn these hard lessons as a company because we've been operating for about 5 years. We started out with Wi-Fi, we started out with cellular, dealing with these issues, and ultimately nothing in any environment that we've dealt with has matched up to LoRaWAN and the LPWAN type of technology. So one of the challenges is when you're assessing these projects, how do you identify what the key features are? How do you identify what's important to you? And so I sort of borrowed a little bit from Deloitte on this because they have a pretty large IoT division where they're purchasing quite a bit within that sector. They're looking to monetize those solutions. And basically the way that they focus and the way that they align this when viewing new technology is a combination, this three-pronged approach, which is pretty sound, to focus on financial metrics, operating metrics, as well as transactional to relationship. So if they can, increase revenues, gain insights across cross-functionally that will bring more revenue into the assets, that's a huge value. Decreasing costs in terms of operational costs associated with loss and efficiency of systems, insurance premiums, or deductibles. These are all elements that people are looking at as it relates to whether they're going to adopt technology or not. Improvement in asset utilization is a huge one, so the ability to either reduce or improve the way that people are utilizing that asset to extend the life cycle. And then as well, in terms of operating metrics, everything is basically focused on the improvement and the improvement in facilities, product, and customer life cycles. So essentially extending the life of all of that and being able to provide more efficiency in that environment, and then also being able to transform environments from transactional to relational. It's one thing that I see consistently inside of these environments is there's pretty high turnover when it comes to the operators in a lot of these environments. And without the ability to, database the information and give new staff context for when they're coming in for when an issue is taking place, because usually it's like the new guy starts and all of a sudden that day, that's when the pipe goes. But if people have some context and understanding historical problems and historical issues inside of the environment, they'll understand what's coming down the pipe in the future, and they'll understand how to avoid that. So one specific industry that's interests really lie in understanding the correlation between what's going to happen today and predicting future events is these guys over there, the insurance industry. And so I'm just going to sort of pose the question, but how is the IoT ultimately shifting the insurance industry? And a lot of what we're seeing, because we work quite closely with insurers, is that basically insurance providers are shifting to service providers and solution providers across the board, in that there's a much greater focus on telematics, on IoT devices, because it's going to allow them to reduce risk inside of multitude of environments, whether you're talking about property and casualty or you're talking about personal lines. And basically hardware is pretty much there as a means to an end. It's not a hardware play, it's all a service play at the end of the day. If we can leverage that data to understand the risk inside of these environments, we can either give people preferential rates on the basis of that or freeze their rates, although I'd say the likelihood is there's going to be more of a stick than a carrot at the end of that, based on what we've been learning. And by leveraging behavioral learning, AI, how do we take that data not only to avoid and to mitigate an acute loss scenario taking place right now, but how do we take that data to avoid future loss scenarios based on what we're learning? Picking up relative humidity, ambient temperature data, how is that valuable across a building environment? So as we sort of see, it's not just the insurers that are driving that. What we're seeing is actually on the consumer side, consumers are interested in this as well. And based on market feedback, you're seeing about 60% of consumers are interested in fire, theft, and water devices. About 75% of them are willing to share their data with their insurers. And about 40 of them on a consumer level would be willing to switch providers on the basis of being able to get this technology in place. And about 40 to 50% are interested in additional services from their insurers, because everything is sort of just becoming a line. Like, I just feel like the market is sort of a big vertical integration machine, let's say, where everybody is looking to take advantage of each sector and be able to optimize what they're doing. So when consumers are driving this growth, it really validates areas on the B2B side for people making purchase decisions, because ultimately, if it's a condo project and you're looking to sell off those units or looking to sell off the assets, you need consumers to see the value in what you're putting inside of the building and to drive more cost on that end for the purchase. And it gives operators the ability to see, okay, we can monetize some of these services now because people are seeing value, they want this, and you're now being compared to a variety of assets across the market that are looking to invest in this type of technology. So when we look at this from a global perspective, we see that this is a pretty heavy burden to pay if, let's say, people are not engaged with this process. It's really difficult, and ultimately one massive burden is going to be on property owners and contractors. This is just more personal lines stuff. As you can see, average insurance claim related to water damage during course of construction is about $138,000. Typically, I've seen numbers more in the millions when you're dealing with high-rise projects, especially when you're near to substantial completion. That's where you really have some major issues, and there's major overruns on builders' risk policies as a result of that. But one of the interesting things that we've seen from insurance carriers is that insurance payouts have gone up by a significant margin. It's about $13 billion across the U.S. is related to water damage, and about 71% of all real estate insurance claims are related to water damage on a dollar basis. In addition to that, about 1 in 50 homeowners filed a water damage claim between 2013 and 2017. So we're starting to see some major shifts in there. And then the environment is another factor, as it relates to understanding consumption, understanding the usage of water, whether that's in an environment inside of a municipality. It's about 3% of all greenhouse gas emissions are coming from water waste processing and treatment. That's, 1 trillion gallons annual wasted water, about 11 million homes amount of consumption. And I think just based on a regular consumption statistics, about 14% of all water that's consumed is actually lost water. So if we can cut that number down by 5%, 10% incrementally, there's going to be massive impacts across the globe as it relates to conservation and as it relates to how much energy we're using in order to deal with this. We were fortunate enough to be participating in basically a water damage risk webinar with Aon recently. It was a couple months back with some of their top customers. And here are some of the insights that we sort of picked up from this, which are pretty interesting, I thought. Basically, if any of you are in the market, I'm sure you're experiencing some of this, but this year I've noticed deductibles are increasing for everybody, premiums are increasing for everybody, and part of that is the risk is not in line with what people are paying currently, and it's actually just getting worse and worse for these insurers. So some of the key ways that we're seeing coverage and pricing changes as a result of water damage prevalence is insurers are seeking higher deductibles, and in some cases we're seeing higher than all other perils deductibles is going to be the case as a result of this water damage. Premiums are being increased based on loss ratio targets. So what you're seeing is about loss ratio targets can range from about 40 to 50% depending on the portfolio. But one of the most key learnings that we're seeing is if insurers view premium levels not where the reasonable expectation of profit is, they will not offer to insure. And that's happening quite prevalently across the market right now. And like I said a little bit earlier, I highly doubt that in the commercial space it's going to be a carrot, it's going to be more of a stick. And based on what our learnings are, it's just going to be a matter of collecting enough market data over a long enough period of time to ensure that these solutions are effective in these various environments. On the consumer end, it's the carrot. On the business-to-business end, it's going to be more of the stick. And basically, what we're seeing is likely in a couple of years, people won't be able to qualify for a policy without this because, like I alluded to earlier, every single one of these buildings, you're going to have fire suppression, you're going to have security camera systems. You're leaving the largest risk unchecked. About 60% of your building risk is unchecked if you don't have systems monitoring water. And it's a tough educational, let's say, hurdle to get over for a lot of people in operating environments. Just moving forward, we're fortunate enough to be working quite closely with these insurers, and we see that our values are aligned. But one thing we've also seen is that homeowners, at least on the consumer end, are very, very slow to adopt the technology. So just as an example, according to Chubb, about 94% of their homeowners have smoke and or fire detectors, as well as security systems, but only about 1.5% of Chubb customers have water shut-off devices installed inside of their homes. Over 60% of the water damage claims recorded by Zurich in North America could have been mitigated or prevented by water prevention technology. Those are huge numbers as it represents total loss ratio, as it represents total dollars, and just the human capital and the sweat put into this, on a daily basis. In addition, what they've seen is these claims are increasing in cost by a massive magnitude. In the U.S., I think average annual claims costing more than $500,000 have doubled since 2015, as well as those exceeding $1 million have tripled. Part of this is related to poor construction, but also, if you notice, for many, many years, people were building 20, 30-story towers. Now look around the city, you're going to see 40, 50, 60-story towers. They're pretty significant. The size of these facilities are growing because there's these intensification policies across different municipalities in North America, and the servicing and the infrastructure is not there to deal with it. So when you have these losses in those types of environments, just imagine the magnitude of them now, because you have so much more water captive inside of these environments, much higher pressures inside of these operating systems as well because of the size of the buildings, just being able to get the water up and around, that when you experience these losses, the magnitude is actually absolutely massive. One of the things that most people in the market are asking is there discounts as it relates to getting this stuff in? Well, unfortunately, historically, like mentioned before, the premium levels and deductible levels are too low for insurers to be able to provide a discount, because if they experience one major loss in most of these facilities, just take an average, let's say, condominium building across Toronto, I'd probably say premiums are anywhere between 25 to about 100,000, let's say, a year. And I've seen deductibles as low as $5,000 on these buildings. Now, you experience one major loss, the insurer is going to be on the hook for 25, 50 plus years in order to recoup their expenses on that after that's taken place. So how can they really reduce that number at this stage? What they really need to do is, like I mentioned before, they're going to be checking on that data, and we're working with a variety of insurers and brokers across North America to feed some of this data back into the market, get an understanding so that in a couple of years from now, like I mentioned before, it's not going to be a carrot, it's going to be a stick, and you're going to need these things in order to keep up with where things are. Like if it was up to me, just based on my history in restoration and construction, I'd make this code, because ultimately it's by far the biggest risk, and it's not a sexy risk like fire and theft, but anybody who's ever experienced a water damage event that's been significant, I can guarantee you they never want to experience it again. Yeah, as I mentioned, we're feeding a little bit of data back into the marketplace, and we're working with insurers on that. So how are we doing that? Essentially, at EDDY, we use, we're going to be collecting data from our devices across, so our EDDY IQ is actually an ultrasonic meter with a built-in full-port ball valve shutoff. Utilizes behavioral learning to get an understanding of what is normal consumption inside of an environment and what is not. There's a variety of use cases for it. So we're able to, aggregate some of that data. We're able to take daily temperature readings, relative humidity readings off of sensors, be able to detect water in environments where there shouldn't be. And then on the back end, what we're doing is we're using our algorithms, which are on a consistent basis, continually learning about how the environment is operating, because you can't really just set a baseline. Seasonality is going to affect the way that people use water, heating inside of these environments. And so we need to learn what these changes are so that we're not creating false interruptions for building operators that are going to be working there inside of the environments. We're not creating more problems than we are solving problems. And just, the ability to quickly detect leaks and minimize alerts when there is no leaks. That's all part of the learning process, all part of working with operating environments and really establishing business rules that are right for that operating environment, because no two buildings are the same. In fact, you can have two buildings, two towers designed by the same developer, two different condo corporations with all the same facilities inside. Their budgets are completely different. They operate the building in a completely different way, and that's going to affect the way that, really everything takes place inside of the building. Because a portion of this, is going to be mechanical failure. But then there's a huge portion of it that's going to be human interaction with the systems. So just as an example, here's sort of our suite of products. As I mentioned before, there's the EDDY IQ in the top corner, ultrasonic meter with built-in shutoff valve utilizing behavioral learning on the bottom left. We have our H2O sensors, which are wireless small sensors that are extremely adaptable. They can go across domestic distribution risers, across suites, across panels, basically in any environment inside of the building where it's able to track things like the presence of water inside of the environment, able to track ambient temperature data, able to track relative humidity data, and that drives some significant use cases when you're talking about domestic distribution risers or hydronic risers where people aren't sticking their heads in there to see anything. If we're able to get data that's going to inform us of losses happening in the future, for instance, when you have a pinhole loss inside of a domestic riser, it's not going to experience water presence necessarily on the floor there and start pouring out. As soon as that pinhole happens, what you're going to see is insulation is going to start wicking up that water. Now, if you have a device in place that's able to read things like relative humidity and ambient temperature, what will happen is we'll be able to detect, okay, there's an increase in relative humidity, there's going to be a drop in temperature as a result of their moisture being in the environment, and there's also no air exchange. Well, we're able to build up predictive and preventative maintenance lists across the building where, let's say, there's going to be latent potential water issues, not acute. And in those cases, on a weekly basis, operators will go across the site and they'll find these issues. They'll be able to correct these sources. They'll be able to deal with those problems before a loss happens and that riser blows out in a month or 2 months from now. So it's not just about detecting and taking action via automation right away. There's also an element where we want to learn about the way that these buildings are operating so that we're able to detect what's going to happen down the line and avoid those losses and additional expenses. One of the limitations that you'll see with a lot of systems, and that's the limitation that we have with our IQ, is it only goes up to 1 inch in size. But we have a solution for that at EDDY. We utilize, right there's 2 devices, shut-off valve and our EDDY Link. Shut-off valves range from 1/2 inch to about 10 inches in size, so you can pretty much actuate a pipe in any building that you'd have, because I doubt many buildings are going to have larger than 10-inch pipes. And then a device like the Link acts as a controller. It's a low power, low voltage, so you're not taking a massive draw off the building. And it also acts as an infrastructure bridge. So for pre-existing, let's say, infrastructure, you might have remote meter reading across these different areas where somebody has to climb up a ladder to read a register, or you need to do a drive-by or a tap read, whatever. If let's say your meters are operating on Census, Badger, or Neptune protocol, we're actually able to tap into those remote reading infrastructure, turn it into automated metering infrastructure, and keep that information captive for you along those ways. And not only can you do that, but based on what you're learning inside of these environments, you can also shut water off during events that aren't supposed to be taking place. And then, as I mentioned before, we leverage LoRaWAN for our communication infrastructure because we found that from a use case perspective, nothing has done for us what that has. It's extremely robust and basically deals with all of the limiting factors that we see in these environments with the concrete, with the rebar, with all of the insulating factors which are made for the efficiency of the building. We do have our own management dashboard, but one of the key things that we see is that in these environments, you have to be able to integrate and work with other players inside there. While the management dashboard is great for certain elements like deep dive analytics, what you really want to have is you want to have a system that's going to be able to integrate with your business flow processes, be able to integrate with your building automation systems, so that when, like I mentioned before, when action is taken, corresponding areas of the system are not damaged, and that you can follow the right processes that work with the way that you operate as an environment. Because otherwise, that's a big challenge for people looking to take on these IoT projects, because you've got disparate communication infrastructures, different languages that they speak, and if they're not communicating with each other properly, then it's pretty much a standalone useless systems a lot of times, unless it's a really, really pressing use case. So just discussing a little bit about LoRaWAN. As mentioned, I think I mentioned 760 kilometers was a clear path record that they created actually at the Things conference, I believe it was last year. What they did is they had a speaker talking up in the microphone similar to how I am right now. They had a LoRaWAN gateway there which was projecting a signal up to a satellite in space, coming back down, and basically on a typewriter sitting next to him, it was typing out his speech as he was giving that. So this is extremely robust communication infrastructure designed specifically for high interference environments, designed specifically to deal with the elements that you're going to be concerned with as you're deploying this type of technology inside of your buildings. But as you can see, there's been some major adoption. About 80 million units are on the market as early as 2019, and the expectation is to be over 1 billion devices supported by the end of 2019 within the LoRa network. So I'm just going to jump into a little bit on the case studies. So here's just an example of a building, and I mentioned a little bit about the equipment. So that equipment in different various deployments was put out in all these different case studies. So this building, as an example, was a tell you a little bit of a story on this building. There's a building in downtown Toronto. I won't use any names, but it had a one-directional washer hose installed backwards. Flooded out 50 units, caused over $5 million in damage, over 50 residents displaced, and the insurance company pulled coverage on the building. This is actually what pulled us into the multi-residential space. We came in there, we provided just a sensor-based solution for these guys. Within the first 6 days, we caught over 21 losses, all across the building from distribution areas to the suites. Since then, the developer who put up that building has determined, okay, any new inventory I'm going to put into the market, I want your system built into my APS. So I want it to be built right into the spec documents, right off the bat, built into the infrastructure of the building, because the cost of getting these systems in these environments while you have a construction project going on is significantly lower than dealing with an operating environment where you've got existing residents or tenants, especially in the multifamily space where, you know, if you can take in any more money, you would be doing it today, and anything else you're adding on as technology just becomes a line item cost. It's a really big challenge in a lot of these environments, because there is huge value, and you know, determining the ROI on something which hasn't happened yet is really difficult for a lot of these guys. So that's just the story of this building, and one example of how we're feeding some data back to these insurers who are making some, you know, decisions about how do we support and how do we, you know, work with these different technology companies. So here's an example on a recent deployment where we were monitoring the hydronic makeup lines on some of these buildings to determine whether there's losses downline. And guys, if I'm going too low, somebody just raise your hand up and say, I don't understand what you're saying. Basically, we're monitoring the consumption on these lines, and in these hydronic lines, unless you have, let's say, maintenance activities taking place, backwash cycles, somebody bleeding a line, things of that nature, or maybe they're just getting rid of some rust, derusting on the interior there, you should have little to no consumption on these lines. Some of the data that we're getting on these lines is blowing the minds of the consultants and engineers and the actual operators, because they have never been exposed to this information. So just as an example, we caught a building going on one hydronic line at about 500 liters an hour. We caught that within the first couple of minutes, but that's what the flow rate was dictated at. If that would have gone on for a long enough period of time, you're talking about thousands and thousands and thousands of liters of water being used without anybody knowing about it, because ultimately the way that this presented itself was the mechanical contractor who built the area had piped the pipe going right into a drain. So it wasn't presenting in terms of water damage issues, wasn't presenting in terms of a loss down line, but they were consuming so much more water than they needed to. So eventually they would have found out if they hadn't done it based on what their water bills would be a few months later. But in addition to that, the efficiency of the equipment on site that they're using becomes degraded when these parts of the systems are not operating optimally together. And so the lifespan of the equipment is significantly limited. And also the way that it operates with the rest of the system can cause potential damage through water hammering, through additional pressure that wasn't supposed to be there, where, you know, we've seen issues, like just as an example, on, it's not in a case study, but this happened about 2 weeks ago on a construction site for a developer that we were working with. They had basically an open pressure relief valve after they were doing some pressure testing. And this was just post-occupancy, so it's pre-registration for this condominium. Basically, they had a loss taking place which was flowing at 90 liters a minute. We caught it within 30 seconds based on the top-up consumption on these lines, as well as sensors which were all coming into contact water inside of the mechanical penthouse virtually immediately. Now, how would they have normally found out about that loss? Would have been coming down the stairwell and probably destroying all the units in its path and all of the finishes, because they're already at substantial completion, going down the building. And so we were able to mitigate what would have been millions of dollars in loss, almost guaranteed, to zero loss, mop and towel cleanup at the end of the day inside of the area, because we were able to shut down the line, we were able to shut down the source of the issue, and we were also able to detect it immediately. So the latency period on when you're being able to get the information and being able to take action is a huge factor inside of these systems. Here's an example. Last summer we'd won a pilot with the City of Toronto, an urban innovation program, and inside of one of these buildings we had a 30-day pilot. Fortunately for us, but unfortunately for the building, they experienced some events. But fortunately for the building, we were in there while they experienced those events. So just as an example, here inside of this building, they had a riser loss take place from the 7th story. which went down to about the 3rd story. Now, inside of there, what we can see is leak from 601, leak from 601, leak replacement from 601. But what you can see is within the bathroom riser, going across the stack, there's a pattern of water presence. Now, somebody wasn't paying close enough attention, and that's part of the challenge with the IoT is about 80% of the notifications which go out are actually ignored by operators and ignored by consumers. So part of our value proposition is we also have a back-end monitoring center, which will take action if, let's say, the operator doesn't take action within a certain period of time. But basically, if, let's say, they were reading the data a little bit closer, what they really would have seen is this started out as a pinhole. And we were actually registering the relative humidity data going down these riser stacks before the leak had taken place, right? And so had they been looking at that, they scheduled the correct preventative maintenance to be able to see what's going on inside of those areas, they actually would have avoided the loss. But just the fact that the loss took place while we had the system in place allowed them to, because they only had sensors inside of their domestic risers, allowed them to shut off their water far faster and know about the issue far quicker. Otherwise, they would have found out about it pretty much when it started going through the podium and when it started going through the lobby, which has happened in all of these buildings before, and that's usually the way that they find out about these losses. Same building, post-pilot, we caught a variety of issues inside of this building, pool pump room, which was created by user errors, because, there's lots of, dozens of contractors walking through these sites any given day or week, which are, they don't necessarily care about the way that you operate inside of the environment. We caught losses from toilets as a result of it being caught in the risers. Would have been even faster if we had in-suite sensors and we'd be able to take action quicker. There was one unit that was in the middle of being turned over, and during the renovation process, the contractor decided, I don't need to drain the riser. And so we caught a loss as a result of that. But just on this building alone, year over year from 2018 to 2019, we took their claims down from 70,000 to 25,000 in the following year, and we were only in there for about 7 months. So we showed a real tangible benefit to that building in terms of their budget and also the headache that they've dealt with on all of these issues. In fact, we've even changed some best practices inside of these buildings as it relates to the way that the tenants use water, because we're picking up data across some of the common areas, which shows people are misusing the facilities, which allows them to place signage and change the way that people are interacting. Because like I said, a portion of it's going to be mechanical failure. There's going to be a large portion of it which is going to be user interaction and errors. So we're nearing the end of this. So just to sort of recap, water risk by far is the greatest risk inside of the built environment, hands down, no questions. Is that right, Intact? Okay, straight from Intact. Perfect. And as we've seen through some of these use cases, through some of the data, the IoT truly has the ability to transform the way that people look at risk and efficiency inside of these environments if implemented properly. Dangerous because there's a lot of noise in the marketplace. There's a lot of companies that are trying to make a name for themselves, that are trying to push themselves and trying to do too much. That's a really dangerous thing. And so you got to be vigilant as it looks at that, but that comes down to understanding the fundamentals like we talked about a little bit before, sort of the Deloitte type of methodology when you're understanding what your use cases are, what your best practices are, no different than you would assess any other problem inside of your line of business. In addition to that, communication infrastructure is paramount to the ability of these systems to be able to operate. If you have the wrong infrastructure in place, you could have the best idea in the world. It won't make a difference because you're not going to be able to get the data from your endpoint devices. In addition to that, automation and integration between systems is also key in order to have truly efficient and truly connected and smart buildings. Otherwise, it's people just jostling between different dashboards and nothing correlates. And so that's really how you leverage and maximize your data. But I think one of the greatest learnings from this is that the risk of inaction will actually just continue to drive the cost of operating up. Like, there's zero question about it. This problem is getting worse and worse over time. And one of the key issues as it relates to this is that, unfortunately, when it comes to development, it is a bit of a, buildings are basically just an investment vehicle, right? And a lot of times it's a financing project, which if it wasn't a building, it would be something else. And so people are thinking more with their wallets as opposed to the duty of care and the actual quality of the asset being passed over. And so it brings up the question of, where does the collective responsibility lie? Who is responsible for taking on the cost of this technology in order to mitigate risk for everybody? And that is the conclusion. Thank you guys very much.